Hello, my name is Charlotte Olds. This is my second year at the University of Oregon, and I am involved in research within Brice Kuhl's Cognitive Neuroscience Research Lab. This past summer, I was fortunate enough to be a FYRE Award recipient, and the project that I worked on investigated hippocampal context differentiation and its impact on memory organization. I worked with my PI, Brice Kuhl, and my mentor, Lindsay Ray, on this project. So before I introduce the methods, I wanted to go over some background information specific to the scope of the study. So free recall is a critical piece of episodic memory, which is a processing system responsible for encoding, storing, and retrieving particular experiences or events. Free recall occurs when information is retrieved from one's memory without a specific cue and has very valuable insight into the organization of memory. The hippocampus is attributed to forming and consolidating long-term episodic memories and can bind individual stimuli with the context that they were originally encountered in to create a context-stimulus association. And this association is instrumental in the organization of memories and affects the sequence that a list of items are retrieved in during free recall, which is often referred to as a recall transition. And this transition suggests that participants engaged in free recall often exhibit a tendency to remember items that share similar contextual cues, which is illustrated in this picture here. So if someone recalled an image of a pool, they would be more likely to recall other pools that they may have seen altogether in this first context. And hence, the retrieval order of items is influenced very strongly by the similarity of the context that they were initially encoded in. And context-based organization of free recall underscores the connection between the organization of memories during free recall and then the representations generated in the hippocampus. Although the hippocampus orchestrates this organization, it also has trouble differentiating between similar contexts, which leads into the next portion, which is on memory interference. So memory interference is a disruption caused by the presence of similar or overlapping memories during the retrieval of specific information. A primary source of memory interference arises from the overlapping features shared by distinct events or experiences, and this overlap in context can cause difficulties in discriminating between similar memories. Additionally, the hippocampus is attributed to actively differentiating similar memories to mitigate this interference. It is also involved in the association of individual memories with the specific context that they occurred in to guide the order that items are remembered in, as seen from the free recall tasks. Yet the hippocampus differentiates similar memories, especially when dealing with experiences that share common elements or features to help reduce interference. The hippocampus also employs mechanisms such as repulsion to facilitate the creation of distinct neural representations for similar events. This suggests that the hippocampus plays an active role in to reduce interference and enhance memory discrimination. And this figure right here illustrates this effect. So A and B could be two images of two different pools that are very similar to one another, and then C and D could be images of two libraries, for example. So in the second graph, with hippocampal repulsion, A and B are separated in order to distinguish them from each other by making them more dissimilar. And as a result, A and C are now more similar to one another than A and B are to help differentiate the very similar scenes. So the research of this study investigates how the hippocampus balances its organizational roles while engaging in interference reduction in memory. On to the methods. The purpose of the study was to investigate memory interference from hippocampal repulsion and its effect on context-based organization of memory. So the hypothesis was that similar context repulsions in the hippocampus would be related to a decrease in the recall of items with similar contexts. So here is an experimental overview. So the behavioral study design consisted of two parts. The first portion exposed participants to the scene stimuli consisting of 32 images, half of which were in the high experience condition, and then the other half were in the low experience condition. And then a cover task was displayed that asked participants to press a button if a red cross appeared. And then in the second portion, it tasked participants with completing 8 blocks, with each block consisting of 3 parts. So as depicted here, there was a learning phase, a distractor task, and then a recall portion. And in the learning portion, they're presented with alternating visuals of a scene and a two-syllable noun. So here's what one block looked like. And in each block, it was composed of 4 different scenes, 2 of which were paired with pairs of a similar scene, and then the other 2 were pairs of unrelated scenes. And these scenes repeated 6 times, each time with 6 unique words, resulting in a total of 24 words per block. And then the distractor task was added that asked participants to complete simple math equations to prevent rehearsal of the other words. And then after all the blocks concluded, the participants were given 2 minutes to recall as many words as they possibly could. So a big portion of the study was generating stimuli. The images chosen needed to be very similar. For example, they needed to have similar lighting and be pictured in the same angle, but they could not be identical, otherwise participants would struggle to effectively recall them or even remember them. And man-made scenes were exclusively incorporated as opposed to scenes that depicted nature because they would be easier for participants to differentiate them. And then I searched through images from projects of other lab members when finding stimuli, and then I also heavily relied on reverse Google image search to find these images. And some of the categories I found and included were soccer fields, classrooms, hallways, streets, etc. I also went through and created a word list. The main criteria for these words was that they could not be shown in the scene. So for example, the word mirror could not be used if the scene depicted here of a bedroom was shown because there is a mirror on the wall right here. This prevents a participant from remembering a word better because they saw it physically displayed. And the words could also not be closely related. So for example, the word truck would not be ideal if the word car was already used in the word list. And then since audio was being recorded, I also removed words that sounded very similar to one another. So for example, baker versus banker. All right, the biggest portion of this project was learning how to code. So the first platform I used was Inquisit, which is an experiment coding software where you can code up an experiment to show participants. This platform was used so the study could be published online to the site Prolific, where we could also recruit participants. And before coding the experiment, I learned the language by practicing manipulating different aspects such as changing or inserting words, alternating the font size, inserting images, etc. And then when actually coding the experiment, the first task was to enter the stimuli and create text files to ensure images were randomized for each participant. And then I could begin creating trials and blocks to finalize the experiment once these stimuli were incorporated. So when collecting free recall data, it came in as an audio file, so it is necessary for me to transcribe the file into text. And over the last year, I learned how to transcribe this data using the software called Total Recall. And I've had sufficient practice using this site for when we do get the data. And then in preparation for data analysis, I worked through a textbook and learned how to code in R. And I really enjoyed self-studying because it was like a really great opportunity for me to get a really comprehensive understanding of how to analyze a variety of different data. And I began understanding how to manipulate code, create graphs, and organize the data that we will receive from participants. So now in the present day, we are waiting for IRB approval on an addendum submitted that allows us to record participant audio. I believe we can begin data collection within the next 2 weeks. So once we get this approval, we will start the data collection process, which will only take a couple of days, and then we can begin analyzing the data. In terms of future directions, the data obtained from this study will serve as a precursor for MRI studies down the line. So here are a list of sources that I referenced throughout this presentation. And to conclude, I would like to thank my mentors, Brice, Kuhl, and Lindsay Raitt, for their continued support on this project. And then I would also like to thank Casey Berg, Lance McCormick, Kevin Hatfield, and then the rest of the CURE staff for enabling me to pursue this opportunity. This has been an extremely valuable experience for me, one that will definitely benefit me in my research endeavors here at the UO and then throughout the future. Thank you very much for listening.